Okay, in the last video, we talked about rotation and we were moving figures around. And during that, I talked about the quadrants. I just want to make sure that that's super clear that this is quadrant 1 using a Roman numeral. This is quadrant 2. We go clockwise. We start in the upper right corner and we go clockwise. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. X and Y are positive in quadrant 1. X is negative and Y is positive in quadrant 2. In quadrant 3, everything is negative. This is why where the expression came a few years ago. You're so quadrant 3 meant you're so negative. And then positive, negative for X and Y in quadrant 4. Okay, just to make sure that we get that in there somewhere. Maybe it comes up in chapter 13, but very important to know. All right, so this section we're going to talk about dilation. So the term dilation, D-I-L-A-T-I-O-N, means to make something a different size. So if you have two figures that are similar, these are two similar triangles. If you started with this one, you could enlarge the triangle, you could dilate it, you could make it larger. The type of dilation would be an enlargement. Or if you had this triangle, you could dilate it, make it smaller into this one. This would be called a reduction. So there's two types of dilations. The scale factor is by how much you're enlarging or reducing the shape. Typically, a scale factor greater than 1 is enlarging, and a scale factor between 0 and 1, so some of a fraction like a third or a half, would be reducing. And then you have to consider the center of the dilation. In other words, where are you going to dilate from? Are you going to dilate from the right angle and actually like leave the right angle where it is? Or are you going to dilate from some other location? Very often, and certainly in this textbook, they seem to be dilating from the origin. So let's take a look at this shape. I think I'm going to run out of room here. So again, I've split my paper up into four spaces. I've purposely kind of backed my X and Y axis down a little bit because I'm going to dilate by multiplying. And when I multiply, if I'm dilating with the origin as the center of the dilation, I'm going to be going in the upper right direction. Dilation. Okay, so it's nice to actually look at the numbers of this. So we're going to, let's do a scale factor of 3. That is going to be an enlargement because we're going to make it bigger because we're multiplying the shape by 3. And we're going to actually do it with points. So this point here is 2, 3. This point here is 4, 3. This point here is 2, 5. So I'm just collecting my X and Y values. So if we're doing an enlargement of 3, all of these points are going to get multiplied by 3, all the values. So instead of 2, 3, we're going to wind up with 6, 9. So we need to go to 6, 9. Let's see, 6, here's 6, 6 across. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I'm definitely going to wind up going off the page here a little bit, but there's still paper. Let's see what happens. So this is 6, 9. So this is the corresponding point to the right angle with the factor of 3. This is going to be 12, 9. So 12, 9. If this is 6, 9, this is 7, 9, 8, 9, 9, 9, 10, 9, 11, 9, 12, 9 is going to be over here. Okay. This is 12, 9. And then this point, 2, 5, is going to become 6, 15, 6, 15, 6, 15. Oh, this isn't 2, 5 though, is it? This is 2, 6. 1, 2, this is 2, 6. That's 2, 6. So this is going to be 6, 18. So if this is 6, 9, 6, 10, 6, 11, 6, 12, 6, 13, 6, 14, 6, 15, 6, 16, 6, 17, 6, 18. Here's 6, 18. Okay, so our new shape, our new enlarged triangle is 3 times the size, 6, 18. Now, what's also cool about this, when you dilate from the origin, something else that's cool about this. So here, let me make these shapes super obvious here. There's our original shape. Here's our enlarged shape. It's enlarged by a factor of 3. So this side length is 2, this side length is 6, this side length is 3, this side length is 9. We've increased the size of the shape by a factor of 3. All the side lengths have changed by a factor of 3. What else is cool is if you go to the origin, your center of dilation, you can draw a line through the vertices. And they all line up, they're collinear with the origin. It's really neat. It just works out that way. All right, so there's a little bit about dilation. You have just a few problems to do with this. I hope they're fun. Leave plenty of room on the paper, obviously, or you might want to plan out, think about what the question's asking you and decide where you're going to put your drawing. And don't worry about using, use the whole piece of paper if you need to for any particular dilation. Okay, enjoy.